Okay guys, I'm just making a quick video so I can go over the first 5 and the last 5. That was your homework assignment. So when we are naming ionic compounds, remember we're always going to name the cation and the anion. This is typically going to be a metal and then a non-metal. So that's what we have here. So we just go find Al on the periodic table, and when it is a metal, it's just the name is the same as the metal. It doesn't matter that there's 3 fluorines there. We do have to consider whether or not we need a Roman numeral. And remember, we need a Roman numeral for transition metals, but that does not include silver, because silver is always +1 and zinc is always +2. So transition metals other than those, and then tin and lead. So if you have one of those, you have to use a Roman numeral. And remember, Roman numeral tells you the charge on the metal. We don't need that for this one because aluminum is always +3. So we just call that aluminum. And then we go find fluorine, or the F on the periodic table, that's fluorine. And remember the non-metal side, we have to change the ending to ide. So aluminum fluoride. The next one, zinc. I have to stop and think, do I need a Roman numeral? No, it's a transition metal, but it's one of the ones where it's always the same. It doesn't matter what the charge is, it's just the name of the metal. And then nitrogen is nitride. We got to change our ending to ide. Next one, sodium. It's in group 1 on the periodic table, so it's always a +1 charge. You don't need a Roman numeral. So it's just sodium, and then sulfur becomes sulfide. Now with number 4, all of a sudden we have one that is a transition metal, copper. And so we need to know, we know it's copper, but we have to figure out what the charge on the copper is. That's going to go in parentheses. Oxygen is oxide, and we need to go figure out the charge. So let's do that. I'm going to write it here because it's a little bit bigger. So if we have this formula right here, we have to use this side of it. We have to use the anion to figure out what the charge on the metal is. Well, when I go find oxygen on the periodic table, it's in group 16. It's going to gain 2 valence electrons to be like a noble gas. Oxygen is always -2, always. So if this is -2, I think about it as 2 sides, the anion side and the cation side. So if the anion side is -2, and that's the total over here has to be +2 because they have to equal 0. So the question becomes, what charge does this copper have to have if when I multiply that by 2, because I've got 2 of them, I get +2? So the only thing it can be is +1. So this copper is +1. So then I'm going to indicate that here with the Roman numeral 1. So this becomes copper 1 oxide. The next one, tin, is not a transition metal, but it's one of the ones that has to have a Roman numeral. So I'm going to have a Roman numeral. Chlorine becomes chloride. And then again, I'm going to use the charge on the anion to figure it out. So SnCO4. Chlorine is in group 17, so it has 7 valence electrons. Those halogens in group 17 always become -1. So this is -1. And I have 4 of them. So the total over here is -4. The total over here has to be +4. And since I only have 1 of these over here on the cation side, then the charge of that one thing has to be +4. So this is 10,4 chloride. Okay, for the last 5, this one here, copper 1 sulfide. So when I'm writing the formula, what I need to figure out is what the charges are, and then from there the ratio. So copper, this is +1 because that's what the Roman numeral tells us. Sulfide is in group 16, so it's going to gain 2 and be -2 charge. So if this is +1 and this is -2, I'm going to need 2 of those. So my formula becomes Cu2S. For this one, aluminum has 3 valence electrons. Metals lose their valence electrons, so it's going to be +3. Oxygen's always -2. So then for my ratio, I'm going to need 2 of these and 3 of these. Because if I have 2 of these, this would be 6 + 6. And if I have 3 of these, this would be -6. And that's this formula. For the next one, silver is always +1, chloride's -1, so that's a 1-to-1 ratio. So that is just AgCl. For the next one, +2, that gives us our charge. Iodine's -1 because it's in group 17, it just gains 1 electron. So I'm going to need 2 of these for every one of those. So Cu, I, 2. And this last one, strontium, is in group 2, so it becomes +2. Sulfide becomes -2 because it's in group 16, and so I just need 1 of each. So hopefully that helps you guys figure out how to do the rest of them.